Alright, so here I'm going to be talking about block diagrams. First of all, what are block diagrams? Well, easy. You understand there is a block in your diagram. So just a normal, I might make a rectangle, okay, with a function in it that I'm going to call g of s, and he has an input that we're going to call u of s, and then he has an output, which is our y of s. Now, this is a linear time invariant system. And y is just going to be the product of our input, u, times our transformation, which is g, or what's in our block. It means that we have u as a value u that goes inside, gets multiplied by g, and then gets out as y. Right. So we have many things we can do with this. The easiest thing, for example, are multiplications and additions. So we can say, for example, that instead of having multiplication, we have u of s, so our input, that goes in our block. Actually, sorry, that has a circle here. Sometimes you will see a sigma for the addition. So I'm going to put plus here, and then I can put here a minus, and here I'm gonna give a I'm gonna give another input, so I'm gonna put u2. This is just an example, and so we have here our y of s, and we can say the y of s is equals to u of s plus, sorry, minus u2 of s. Now it's a very simple example, but by putting these two together, so by putting the multiplication and addition together, we can say, for example, that we have an input u of s goes in to our block diagram. So we have g of s here, and we have our output over here, y of s. Before we get output, we actually get something out, and that goes as a feedback inside our thing. So I'm gonna say, I'm gonna move a little things a little bit around. So I'm gonna say that here is a plus from our side, and then there is a minus from here. Again, I can put a sigma here. Makes it easier at the beginning, but I will stop toward the end. So here, as you can see, we have our u that goes in. Let's say this is 0 for the moment. So we have our u that goes in, gets multiplied by g of s, and then this exact thing gets subtracted from u to give us y of s. All right. Uh, Another way to write this actually is by saying that y of s in terms of our input, which is our u of s, is equals to g of s over 1 plus g of s. Now we can test it out by taking our equation over here in the column, and then we just take out the u of s. So we have u of s, and then times 1 minus g of s is equals to y of s. So for some reason here I'm getting let me check what my calculations what I have for says. So we have our input minus, you know what I can do? I can call this part here, I can call it y of s. I'm gonna make, actually, I think this is just a little bit more complicated than I realized was explaining it. In fact, I took some steps that were not allowed. So I'm gonna say that we have our input, and I'm gonna call r of s, which is what you're gonna call it from now on. and then we go and we add it to something, and we're gonna have a feedback later. And here we get out something I'm gonna call what u1 of s. Then we're going to a g1 s, and it gets out, and then we get a y of s. However, I get a feedback here, and here I have another block, g2 of s, and here it goes back in here, and we have a minus here. Now I can call this y1 of s, and this u2 of s. Now, as you can see, the round part here means plus or minus, and then the square means times. And of course, if I want to divide from the divider, I can just do 1 over g2 of s for the bottom here. It'll be the same thing for the divided. Alright, so I can say that I'm gonna call this y2 of s. So I'm calling every single input. So I can say that we have r of s minus y2 of s to be equals to u1 of s. And then we say that y1 of s is equals to u1 of s times g1 of s, because we take the u1 multiply and then we get the y1. And then I can say that, well, y1 and u2 have the same thing. So I can just say y1 of s is equals to u2 of s, same thing. And then y2 of s is equals to u2. Sorry. Yeah, sorry. u2 of s times g2 of s. And of course, our y is equals to our final y of s is equals to our y1 of s. Okay, so what I want to have in the end, what I want to have in